Hey everybody, Mr. Elliott here. I have three cool things to show you before we start the lesson. First one, this is from Kyla's Christmas party down at her daycare. This was her eating some kind of veggie chip thing, and an orange, and some potato chips, and a cupcake. But she actually doesn't like cupcakes yet. She doesn't. She looks at them. She's like, ew, yucky. So she's not into cupcakes, which is really good. As a parent, we're going to get that up on the wall. And then I have some artwork for you. Check it out. What do you think? It's nice. For a big Michigan fan, after this college football playoff, I thought it was appropriate to think that this was Kyla painting UW getting like wiped all over the floor by Alabama. Sorry, UW fans. Anyway, let's get this up on the wall so that you guys can watch Kyla watching us do math all the time. Sounds pretty fun. And this one. If you're curious what her tools were, she was using forks to do the painting. Can you imagine? You can paint with forks. This is the other cool thing I wanted to show you. My document camera, I turned it to the side. And then if I bring my hand up here, there, like this. Oh yeah. So look, from the screen it's coming on the bottom, but then on this screen here, my hand's coming in from the side. Whoa, what? Oh, look, I'm gonna give Elliot a high five. Kind of worked. All right, let's get to math. That was 2 minutes of life that you're never going to get back. Sorry, students. So we're doing advanced completing the square problems today. I know I titled it completing the square when a is not equal to 1, but if you look at this first example, a is still equal to 1. What makes this one more complicated is this 3 here. I don't know if you noticed this, but in my previous lesson, this b term was always even, which meant that it worked out mathematically nice. When it's odd, it mathematically doesn't work out quite as nice. But as we talked about in the previous lesson, you take this 3, divide it by 2, and square it, and that works out to be 9 over 4. So this is what you need to add to both sides, or not to both sides. This is what you're going to need to add and subtract. So it becomes x squared minus 3x plus the 9/4. And then like we've always done before, if we're going to add 9/4, we also need to subtract 9/4, and I still need to subtract this 5. This thing, as we did before, you can think of it one of two ways. You're either taking the b and dividing it by 2, 3 over 2, or the square root of 9 over 4 is 3 over 2, and there's a minus here. So it's going to be x minus 3 over 2 quantity squared. Then negative 9 over 4 minus 5. 5 is equal to 20 over 4. So if I went negative 9 over 4 minus 20 over 4, I'd get minus 29 over 4. So it's nothing tricky. It's just a problem with, well, it is tricky because it has fractions, but it's not any different than what our previous lesson was. Just harder numbers. Example 1. Example 2 and example 3 on this is when this b value or the a value is not equal to 1. Now, truth is that you cannot do completing the square when there's a 3 attached to the x squared. So what we do is we're going to factor this 3 out so that it is just an x squared. And we want to factor the 3 out of the first 2 terms. We don't really care about the 22 though. So I'm going to put parentheses around the first 2 terms, factor that 3 out, and what's left on the inside is x squared minus 6x. Now I can do completing the square, but I need to do it inside the parentheses. If you take 6 divided by 2 and square it, that's 3. 3 squared is 9. So what I'm going to be doing is adding 9. Now, in our previous examples, after we added 9, we subtracted 9. But you got to be really careful because we didn't actually just add a 9. We added 3 times 9. which is 27. So I really just added a 27. So on the outside, I then go minus 27, and then I still have that plus 22. Soak that in for a moment, everybody, while I get a drink of water. So once again, I put parentheses around the first two terms. I factored the 3 out, and at that point I had to do the business, the completing the square. 6 divided by 2 is 3. 3 squared is 9. So I added 9 on the inside. But this was not adding 9. This is adding 3 times 9, which is 27. So I subtracted 27. Finish it off. The 3 is part of your answer. X minus square root of 9 is 3. So this becomes x minus 3 quantity squared. And then negative 27 plus 22 is negative 5, and we are now in vertex form. So it's just 2 extra steps. So if you're able to do the a equals 1, these 2 extra steps should make it doable for you. All right, example 3. In example 3 is a challenge problem. Try this one out. 5x squared plus 15x minus 8. The reason this is a challenge problem is that when you factor the 5 out, that's going to become a 3x, which is odd. So it's going to be a really ugly fraction problem. Because this is a challenge problem, I'm actually not going to solve it this minute. I'm going to solve this one at the end of my lesson. But if you want a challenge, try this one out and then see the solution at the end of the problem. Let's get into part 2 in the meantime. Part 2 of this lesson is solving equations, but we're solving by completing the square. And this first one, a is not equal to 1, but if you look at the b is odd, so it's going to be kind of one of those tricky ones that we dealt with from example 1 in part 1. If I handled it the same way that I handled the last lesson, my first step would be to subtract 7x from both sides. So I'd get x squared minus 7x equals 5. Now I need to find a number to add to both sides of the equation. So I take the 7, divide it by 2, and square it, and that's 49/4. And because we're working on both sides of the equal sign, I'm going to add 49/4 to both sides. So x squared minus 7x plus 49/4 equals 49/4 plus 5. But I don't want, I need this 5 with the denominator of 4 at the end of the day. 5 is 20 over 4, so this 5 here, I'm not going to write 5, I'm going to write 20 over 4. Okay, this factors into x minus square root of 49 over 4 is 7 over 2. So all that squared equals 69 over 4. Square root both sides, just like the last ones, and I get x minus 7 over 2 equals, I don't know the square root of 69, but I do know it has to be positive negative. So I'm going to go positive negative square root 69. I do know the square root of 4, that is 2. So then my last step would be to add 7 to both sides. Square root 69 is fully simplified, so I'm going to leave that 69 as it is, the root 69 as it is. And when I add the 7 halves to both sides, I end up with 7 halves. This thing's plus or minus, so it's 7 halves plus or minus square root 69 over 2. Hey, I notice I have a common denominator. These problems will actually always have a common denominator here. It's just kind of how they work out. And my final answer is 7 plus or minus the square root of 69 all over 2. And if you're thinking right now, hey, that's how my answer looked when I was doing quadratic formula a couple of years ago. There's a reason for that. We're going to talk about that next Monday. All right, so this is an example when a is equal to 1. Let's do an example when a is not equal to 1. So suppose I had 2x squared minus 12x equals, this problem actually, quick realizing, this isn't going to work out if this is 55 or 54. I need it to be an odd number. Let's have it be 55. If it was even, I would handle that problem differently. So, okay. just like our last problem, or our last part, we can't do completing the square with the 2 here. So the first thing we're going to do is we're going to factor the 2 out. So I have 2 times x squared minus 6x equals 55. Then I need to do the completing the square. So x squared minus 6x, I need to add something into here. 6 divided by 2 is 3. 3 squared is 9. So inside the parentheses, I'm going to be adding 9. Now, I didn't just add 9 to the left side. I added 2 times 9, which is 18. So because I added 18 on the left side, I also need to add 18 on the left. This becomes 2 parentheses x minus 3 quantity squared equals I think I'm seeing now I had that number there. 18 plus 55, which is 73. Now my next step, I want to square root, but as you recall, we cannot square root while this 2 is here. So I'm going to divide both sides by 2. So x minus 3 quantity squared equals 73. Start over. 73 halves. And now that I've isolated the thing that's squared, I can square root both sides. So it becomes x minus 3 equals, so it's positive negative square root of 73 over 2. I need to do a little side work here. Square root of 73 over 2. This becomes square root 73 over the square root of 2. You multiply this by root 2 over root 2, and you end up with square root 146 all over square root of 2 times square root of 2 is 2. So positive negative square root 146 all over 2. My last step is to add 3 to both sides. So x ends up being 3 plus or minus square root 146 all over 2. You could change 3 to 6 over 2 if you wanted. I'm actually okay with this answer here. But if you want to take it a step further, you could say 6 plus or minus square root 146, all of that over 2. That might be a better answer. But I'm actually fine with both. Okay, we are at 12 minutes, doing all right. I have a challenge problem from this one. Let's say it was 3x squared equals 8 minus 15x. So I want to solve this challenge problem. Before I solve this challenge problem, I want to get to the first challenge problem I proposed for you. So this is the one that I need to rewrite in vertex form using completing the square. So parentheses around the first 2 terms, factor the 5 out. And what's left on the inside is x squared plus 3x. If you take 3 divided by 2 and square it, you get 9/4. So I'm going to add 9/4. What makes this one harder is that then on the outside, I didn't just add 9/4, I added 5 times 9/4, which is 45/4. So minus 45/4. And then I have this minus 8, and 8 is 32/4, so minus 32/4. And then my final answer, g of x is 5, x plus 3 halves quantity squared minus 77 over 4. So it's not a pretty answer, but it's a good answer, and it's an exact answer. People love it. Booyah. And then the last challenge problem, a solve for x problem that looks like this. And I'm noticing it's actually very similar to the other challenge problem I have here. So first you want the x squared and the x on one side, so 3x squared plus 15x equals 8. Factor out the 3, so 3 times x squared plus, no, it's different. I thought it was the same as the last problem. It's different. Factor out the 3, you get a 5, so x squared plus 5x equals 8. And now I need to do the completing the square. X squared plus 5x. 5 divided by 2 squared is 25 over 4. So I'm going to add 25 over 4 here. Now because I didn't just add 25 fourths to this left side, 3 times 25 over 4 is 75 over 4, so I added 75 fourths to both sides. And then this plus 8, let's see, 8 is 32 over 4, so plus 32 over 4. Next step, it becomes 3 times x plus 5 over 2 quantity squared equals 107 over 4. My next step, before square rooting it, you need to either multiply both sides by 1/3 or divide both sides by 3. But either way, when you do that, this 4 on the other side of the equal sign is going to become a 12. Man, this problem's getting ugly. Square root both sides. I got to do a little side work here. This square root 107 over 12. That becomes root 107 over root 12. I multiply this by root 12 over root 12. And 107 times 12 is 1284. So I have 1284 square root 1284 over 12. I got a feeling this 1284 can be simplified further. I know that, so let's do a little more side work. Square root 1284. Let's see, if I divide that by 4, it divides 321. 321 I think is clean, unless I can divide that. Nope. So it's just 4. So square root 4. 1284 divided by 4 was root 321. So this becomes 2 root 321. So back up to here. 2 root 321 over, where am I at? Over 12. 2 over 12 becomes 1 over 6. So this is square root 321 over 6. Whew! So once again, that was how to simplify square root 107 over 12. This simplified all the way down to here. So x plus 5 over 2 quantity squared equals positive negative square root 321 over 6. Oh wait, that was me square rooting both sides. I just dealt with that. So last step is I'd subtract this 5 over 2 from both sides, and I end up with negative 5 over 2 plus or minus root 321 over 6. If you went common denominator, 6 over 6, this would become negative 15 over 6. So negative 15 plus or minus square root 321 all over 6. And yikes, that was my final answer to an extremely challenging problem. Well, the students who want to take a quiz are filing into the classroom right now, so Elliot's got to go. Have yourself a great day. I'll talk to you later. Bye-bye.